This one should be a pretty quick one. We're just going to go over how to make this type of planetary dust ring texture. So, here we go. Alright, so to make this, you need a text coordinate. You want to add negative 0.5 to both channels of that and then pass it into this vector to radial value because we're going to use this linear distance later. Next, you need two radial gradients. The first radial gradient gets a outer ring extent and outer ring density fed into outer ring extent scalar parameter goes into the radius. Outer ring density parameter goes into the density. Inner ring extent parameter goes into the radius of your second radial gradient right here. And inner ring density goes into the density of this one. Next, we're going to run them both through a saturate. And we subtract the inner gradient from the outer gradient. Saturate it one more time to get rid of any sub-zero values. And then we're done with this part for now. Next, we come in here. So I have this noise texture that I created, but you can use any kind of noise texture here. Just you can go render some clouds in Photoshop or something like that. It doesn't really matter. You may want to use packed noise. At least in my case, I'm using red and green. But you could you could just as easily, hang on. You could just as easily hook this in here as well. But I like this because it gets me more variance in the rings. So I have an RGB packed noise here. I'll do a addendum on how to do all the GIMP stuff that I'm using in these at the very end. So we take the linear distance of this vector to radial value that we set up. We add an offset to it. We multiply it. This is a scalar parameter named offset. We have a scalar parameter named frequency. We multiply it by the frequency. And then we plug it into the texture sample of just a regular noise texture, and you end up with this ring-looking texture. Next, we plug in the output that we want to use for our visibility, our opacity, into a smooth step with sparsity scalar parameter divided by 2. I don't remember why I did this. Maybe it was just too big, but I think you could pretty feasibly remove that divide by 2 and just do a smaller number. So let's do, oh, that's why. Okay. So let's do 0.25. All right, there we go. Beautiful. 0.3. So you can kind of see what this is doing to the mask. Oh, that's why. Because 0.5 is your max. At 0.5, you don't have anything. So this actually does make sense. So leave this here. That way you actually have a useful 0 to 1 range. So that's actually good. But put 0.5. Feed it into this smooth step. Alright. Now, down here we have this final mask. That's getting the output of these two radial gradients. We're multiplying it by the output of this smooth step. So what's that do? So let's take a look at what this node looks like, and that'll give us an idea. Okay, so we're using these two radial gradients to form this donut, right? And then we're multiplying that donut by our ring texture output, leaving us with the ring textures masked out by the donut. That's how we get our ring, and all these parameters do is control the size of these two things. Okay. Finally, we take the output from this and we multiply it by the master opacity scalar parameter, and we plug that into our opacity. Next, let's look at our colors. Okay, so we have a warp node with both colors here, We're using our green channel of our RBG noise in the alpha here to basically, that way the noise that we're using, the noise layer we're using is slightly different than our height map, or not a height map, our mask noise, and that's going to give us variance within the rings themselves. The output of this, we then pass to a multiply node, and we multiply it by the scalar value of intensity. This color controls our color intensity that we're feeding into base color. Okay. And then the same output, the same color output here, is multiplied by our mask times our glow. And then that's fed into the emissive color. And if you watched the first video in the series, you will remember that this value is what allows us to take shadows on our ring. Not close enough. Oh, no, I need the black body in here. It's what allows us to take our shadows on our ring but still be able to see the ring in the shadows. If you didn't have a little bit of luminosity, you wouldn't be able to do that. So once again, just zoom out a smidge so that anybody who wants to look at it can. This is what the end of it looks like. From left to right, we've got this. Into this. And we plug into the base color, emissive color, and opacity. Surface, translucent, default lit, two-sided, important that it's two-sided. Let's see what volumetric directional lighting mode, directional lighting intensity at a 1. Okay, so that's pretty much it. Pretty simple one, actually, comparatively. Zoom in here. Actually, I should have done this on the other two, but here's the whole graph. If you want it, you can use it. Okay. Finally, you're going to take this texture and apply it to just a flat plane. That's it. Apply this to the flat plane. And that gives you your planet rings, and you can just control this by rotating it, and you rotate it in whatever direction you want to do it in. Like, you will hit some angles sometimes that don't get very well lit. But, you know, play around with it. I'm sure you'll figure it out. Alright, this was a short one. I'm going to end this one and jump right into the first of the planet videos. Alright, later.